Welcome. This video describes repair and maintenance procedures that can be made to cryogenic cylinders at the distributor level. It's intended for service people who are familiar with cryogenic equipment in general and its safe use in particular. Although we will be reviewing a few selected safety procedures in this presentation, prior knowledge of shop safety and the potential dangers of working with cryogenic materials is essential. The information we'll cover here includes general practices, including the tools and other work area equipment you'll need, as well as some safety tips. Checking and replacing rupture discs and relief valves. Gauge adjustment and replacement for both Roto-Cal and float gauges. Valve rebuilding with a Rego replacement kit. Regulator adjustment and replacement for economizers, pressure building, and combo regulators. And finally, changing the service category of a cryogenic liquid cylinder. Let's begin with a quick overview of the general practices that need to be observed when repairing or replacing cryogenic equipment. First, the maintenance and repair that can safely be done to any cryogenic equipment outside the factory is limited. When in doubt, return damaged, defective, or contaminated equipment to the factory. If you have any questions about a repair procedure or aren't sure whether or not a cylinder should be sent back, call MVE Sales Administrators. They're always available to talk to you about any service problem. And do feel free to call. Your safety and that of your customers depends on it. As I mentioned earlier, this program is intended for service people who are already familiar with the safe handling of cryogenic equipment. For example, for your own safety, you'll need oxygen-clean gloves and safety glasses. Safety procedures and related information are detailed in a booklet from the Compressed Gas Association, CGA P12. You shouldn't attempt to do anything we show you in this video unless you're already completely familiar with the CGA's recommendations. Additional information specific to oxygen service is found in CGA P14. Safety procedures for oxygen are extremely critical. Oxygen, as you know, reacts chemically with oils, greases, and hydrocarbons. Although not flammable itself, oxygen supports combustion aggressively and violently. The slightest oversight can lead to fire or explosion. And no smoking is always the rule. For dealing with fittings and other components, you'll need tools that are oil and grease free. In other words, dedicate a set to this purpose and this purpose only. Don't use a wrench or a screwdriver that you've also been using on your car. You'll need a set of socket and box wrenches ranging from 1/2 inch up through 1 1/8 inch. You'll need several sizes of adjustable crescent wrenches, especially large ones, a 10 inch and a 14 inch. A set of Allen wrenches, primarily for adjusting float gauges, and needle nose pliers for working with the springs that are a part of the float gauge rods. You'll need an assortment of screwdrivers of various sizes, both flat blade and Phillips head. A torque wrench isn't a necessity, but if you have one, it will prove useful. For working with copper tubing, you'll need a tubing cutter and also some sort of bender for 3/8 inch outside diameter tubing. And finally, a flashlight with a narrow extension for inspecting the inside of a cylinder. Your workbench should include a soft jaw vise. And again, all tools and your workspace must be oil and grease free and spotlessly clean. Expendables you'll be needing include Teflon tape, lint-free cloth, halocarbon oxygen grease, and a bottle of leak-detecting liquid. In order to test and adjust regulators, you'll need a special compressed nitrogen setup built around a regulated high-pressure nitrogen gas cylinder. The regulator at the cylinder end you'll be setting for the maximum pressure you'll be needing for any given test. On the way to your workspace, the gas should pass through a relief valve and then to a second, easy-to-reach and adjust regulator that you'll be setting to various values during the test. And finally, it goes to a valve or a fitting that can be adapted to mate with the regulators that you'll be testing. Now, let's look at some additional general practices that apply no matter what repair or adjustment you're making. The first step in dealing with any tank is to identify the service it's been in. Again, if it's been in oxygen service or is going to be converted to oxygen service, extra care is required. To be sure that a cylinder is never used accidentally in the wrong service, liquid and gas fittings have different thread sizes for different services. Check your MVE service manual for the correct fitting. The DOT data plate shows safe operating pressure for the cylinder. A .4L200 rating on the cylinder indicates a maximum operating pressure of 200 psig. A .4L100 would indicate 100 psig. Relief valves may have a hanging tag, but the important value is the one stamped on its side. Make sure they're the same. And there may also be a large label like this 230 psig one, but again, it must match the value stamped into the brass fitting. Rupture discs also have their values stamped on their surface. Check the rupture disc to make sure it's not blown. If it is, it'll need to be replaced. And make sure the sight gauge isn't cracked, whether it's an older float gauge or a newer Roto-Cal one. And make certain all the valves are operational, that the handles turn easily and that they're not stuck in place with corrosion. Before you work on any cylinder, you'll want to make certain that there's no pressure in the tank. You'll need to empty it and allow it to come up to room temperature inside and out. You'll do this by transferring the liquid from the cylinder you're going to work on over to an empty cylinder. Make sure the service is the same for both cylinders. Transfer from an oxygen cylinder to only an oxygen cylinder, for example, or from a nitrogen cylinder to only another nitrogen cylinder. And do it in a well-vented area, ideally outside. To start the process, you'll first need to vent the tank that will receive the liquid. Attach an appropriate muffler to the pressure vent valve, the PV valve. In this example, we're working on a nitrogen cylinder, so we're using a nitrogen-compatible muffler. Open the vent valve, leaving all the others closed. Venting can take anywhere from a few seconds to a few minutes, depending on how much liquid is left in the cylinder. After the venting sound is gone, check the pressure gauge to make certain it reads 0. If it doesn't read 0, and the hissing sound is definitely over, the gauge needs replacing. To hook up the second cylinder, leave the vent valve in the first cylinder open, and also open the pressure building valve in the second cylinder. Again, make certain all the other valves in the second tank are shut off. You'll build pressure in the cylinder to transfer the liquid. Attach one end of the proper cryogenic transfer hose to the liquid valve of the first tank, and connect the other end to the liquid valve of the second tank, the tank that you want to transfer the liquid into. Open the liquid valve on the second tank, and then open the liquid valve on the first tank, and this will start the transfer process. The liquid will flow from the first tank to the second, and depending on how much liquid is being transferred and how long it takes, this hose can become extremely cold. Once the liquid is completely emptied into the second tank, shut the liquid valve on the first, now empty tank, and shut the liquid valve on the second tank that received the liquid. Close the pressure valve on the first empty tank, and remove the hose. Again, it could still be very cold. Wear gloves if it is. After the hose is off the receiving cylinder, close its vent. Here is the procedure for replacing relief valves. Remove the defective or incorrect valve with a 7/16" wrench. After you do, clean the threads of the new replacement with a blast of compressed nitrogen. Never use an air compressor. The air will invariably be contaminated with oil. Wrap the threads with a few layers of Teflon tape. Go in a clockwise direction, the same as if you were screwing on a fitting. Wipe on a thin layer of halocarbon grease. And turn the fitting on snugly, but don't over-tighten it. And position it so the stamped rating is visible, in this case, facing up. Here's the procedure for replacing a rupture disc. They're not repairable. As always, work with only a vented, empty cylinder. And with the help of a 1 1/8" wrench, remove and discard the old disc. Clean the threads of a new one with a blast of compressed nitrogen. Never use an air compressor. The air will invariably be contaminated with oil. Then wrap the threads with a few layers of Teflon tape. Go in a clockwise direction, the same as if you were screwing on a fitting. Wipe on a thin layer of halocarbon grease, and then turn the fitting on snugly, but don't over-tighten it. Position it so the rating stamp is visible and facing forward. Here is the procedure for replacing a Roto-Cal gauge. The first step is to remove any residual pressure from the tank if you haven't done so already. The gauge here shows pressure. In this case, you'd obviously have to vent the tank. But in any case, always double check the vent valve and make certain it's open and the tank is empty. When it is, remove the gauge protector. There are 3 7/16" bolts that hold it in place. When the last bolt is off, lift off the protector and remove the Roto-Cal head by unsnapping it from the post. Discard it if it's broken or defective. Next, you'll remove the long float rod from the tank. You'll unscrew it and then lift it up and out of the tank. Wear your gloves for this. The rod assembly could be extremely cold. And the assembly is almost as long as the tank, so be careful you don't bump into something overhead as you lift it out. In order to adjust the float, you'll first need to snap the Roto-Cal head back in place. There's an Allen head screw at the bottom of the spring. Loosen it, and then move the retainer up or down just a small amount, no more than about a 1/64 of an inch. Tighten it lightly, and see what change it made in the gauge. This went too far the other way. The goal is to have it point at the small dot just below the empty mark. That's just about here. It takes a bit of trial and error. When the pointer finally gets to the dot, tighten the Allen wrench firmly, very firmly. The extreme cold inside the tank can easily unseat it if it's at all loose. Inspect the float for contamination. Wipe the rod clean with an oxygen-clean, lint-free rag. Remove any grease, dirt, or lint. And then you're ready to slide the assembly back into the tank. There's an O-ring gasket that's part of the assembly. Check it, and if it's worn, broken, or otherwise damaged, replace it. And as you slide the rod into the tank, you'll have to feel that it slips properly through the retaining guide. It's about 20 inches down. Inside it looks like this, but you can't see it, of course. But once you have the rod in the right place, you won't be able to swing it from side to side. Finally, you reverse the rest of the disassembly steps. Screw the float assembly back into the tank. It's best to do this with the gauge off. And remember that O-ring grommet is there, so tighten it securely without over-tightening. Snap the gauge back in place. Double check to make sure it still reads 0. Bolt the gauge protector back on. Close the vent valve, and the job's complete. As part of the procedure for changing service of a cylinder, you'll have to replace one Roto-Cal gauge with another. Here's the procedure for replacing or adjusting a float gauge. First, remove all pressure from the cylinder by venting and checking the pressure gauge. Then, remove the 3 bolts that hold the clear protector on. Next, unscrew the float rod assembly and carefully lift it up and out. Discard the old sight glass if it's cracked or scratched, and discard the white tip. And tap on a new white tip. Wipe the assembly clean with an oxygen-clean, lint-free rag. You're looking to remove any grease, dirt, or lint. And then hook the spring back into the sight glass and flip it over the top. Next, you'll suspend the gauge at eye level. Some people can do this by hand, others prefer to make a bracket out of a couple of nails, but in any case, hold it steady, see how it lines up. You want the top of the tip to be near the top of the line. If it is, great. But if not, adjust the retainer with an Allen wrench. It'll take a couple of times to get it right. When you have it right, about like this, snug up the retainer tightly with the Allen wrench. Put the O-ring back on and use a new one if necessary, if the old one's dried out or at all cracked. Slide the assembly back into the tank and make sure that the rod slips through the retaining guide about 20 inches below the top. You'll be able to feel it when it's in right. Slide it the rest of the way, tighten down the assembly, and replace the clear protector cap. If you're changing service with this kind of gauge, you'll have to peel off the old label and put a new one for the new service on as part of the step. Here's the procedure for rebuilding a valve with a Rego replacement kit. Not all brands of valves accept a Rego replacement, although most do. The Rego repair parts come together in a bag. Every part has a purpose. It's important that you use them all in the right place and the right order. After venting the tank and opening the old valve you want to repair as far as it will go, remove the screw that holds the handle on. This can be difficult if it's corroded. You can discard the screw and the parts under it when you're finished. The replacement handle will always be silver. If the old handle is a different color, but it's in good working order, you may want to hold on to it and reuse it. Place a 15/16" wrench over the bonnet, the nut part of the valve. We're making unscrewing it look easy here, but if it's old and corroded, you may need to loosen it with the help of a dead blow hammer on the end of the wrench. It should be possible to remove the stem parts within by hand, discard them. And finally, clean out the valve innards with a blast of nitrogen. There are a few tricks to assembling the replacement parts. First, turn the base down until you can just barely see the threads. This will help it seat quickly and easily in the valve later on. Next, place the stem on the base, and then the Teflon gasket, beveled side down. It nests into the groove. Finally, rest the new bonnet on top. Now, place the assembly into the valve. Put your finger on top of the stem to hold it in place while you tighten down the bonnet with your other hand. Do the final tightening with a 15/16" socket torque wrench that's set for 200 inch-pounds. If you don't have a torque wrench, tighten it until the pipe coming to the fitting just starts to bend. Now drop the two new Teflon gaskets from the kit onto the stem. They make it easier to turn the handle, especially as the assembly corrodes over time. The pieces under the screw are designed to keep the handle in place even if the screw breaks or rusts away. Start with the screw that's embedded in the washer. Slip it through the spring retainer, then the spring, the small brass washer, the white seal washer, and the red seal. Drop the aligned elements over the stem and into the handle, and tighten the screw. All the pieces under the screw are designed to keep the handle in place even if the screw breaks or rusts away. Each element serves a purpose. Don't throw any away, and make sure you assemble them in the right order. Here's the procedure for removing, adjusting, and replacing an economizer regulator. Begin by loosening the copper fitting that connects to the regulator. Then with a large wrench, tighten the regulator a bit in order to twist the elbow off of the copper tube. Then remove the copper tube. And also remove the elbow that's attached to the regulator. Now you can twist the regulator off. Once it's off, and assuming it needs adjustment, you'll be attaching the regulator to your nitrogen test jig. But first, check the flow arrow stamped in the housing. It shows the direction that the gas must go. Attach the regulator. And open and close the incoming gas valve. The gauge on the incoming nitrogen line should drop accordingly. The regulator we're adjusting is rated at 140 psi. It should drop to that. This is too high. To adjust it down, we'll loosen the lock nut that holds the set screw in place and loosen, that is, unscrew the set screw. After adjusting, watch the gauge while you open and close the valve again. Repeat the process until the gauge shows that the valve is calibrated properly. A second gauge attached to the output should drop in the rated setting down to 0 when it's opened. Both sides must work properly or the valve is defective and should be replaced. Before you attempt to reinstall the regulator on the tank, test for leaks. If bubbles show that you found one, discard the regulator and replace it with a new one. Before you reattach the regulator, first remove any residue of old Teflon tape using a wire brush. Then put on fresh Teflon tape, taking care that the tape stays in the threads and doesn't overlap the hole. Wipe on a small amount of halocarbon grease and begin to reattach the regulator to the cylinder. Basically, you'll be reversing the removal steps. Position the tightened regulator so that it's a little beyond where the tubing elbow should eventually be, and attach the elbow. Use a new elbow if the old one was cracked or in any way defective, and point it toward the opposite tubing connector. Then replace or put in a new 3/8-inch copper tube with fittings at both ends. Twist the regulator back into its proper position, putting the copper tubing into its fittings at the same time. This part can take a bit of trial and error and tube rebending. Finally, tighten up the fittings on both sides, and the job's complete. Here's the procedure for removing, adjusting, and replacing a pressure building regulator. Before the regulator can be unscrewed, the copper tubing and fittings that are attached to it must be removed by turning the fittings. Now you can unscrew the regulator. Either now or later, before you replace the regulator, clean the threads with a wire brush. Check for the in-out flow arrow stamped into the regulator and connect the nitrogen line from your test jig to the in port, and connect a test gauge to the out port. Open and close the valve while you compare the upper and lower readings on the gauge against the rating of the regulator. If the pressure is too high, loosen the lock nut and loosen the set screw down below. If it's too low, loosen the lock nut and tighten the set screw. After adjusting, watch the gauge while you again open and close the valve, and repeat the process until the gauge shows that the valve is calibrated properly. Spray the regulator with a leak-detecting liquid. Bubbles would indicate that it's defective and should be discarded. Assuming you've already cleaned the threads with a wire brush, wrap them with a few layers of Teflon tape, and then wipe on a small amount of halocarbon grease. Next, you'll retrace your steps. Twist on the regulator. It can be helpful if you've already attached the 90-degree elbow. Align the two elbows so they point to each other. And align the copper tubing and its fittings. If there's any doubt as to their serviceability, use new ones. And finally, tighten down the fittings. Here is the procedure for removing, adjusting, and replacing a combo regulator. First, before the regulator can be unscrewed, the two pieces of connecting copper tubing must be removed. Their connecting fittings must be loosened at both ends in both cases. And next, the two assemblies have to be spread apart in order to free the copper tubes. Do this by turning the copper fittings until the copper tube is spread just enough to remove it. With the copper off, you can twist off the regulator. Be sure to clean the threads with a wire brush, either now or later before you put the regulator back on. The ports on a combo regulator are labeled in and out. Attach the inside to the compressed nitrogen test jig, and attach a test gauge to an out port. Next, a small flexible back pressure tube is attached from the other out port up to the downstream end of the gauge assembly. Open the nitrogen feed and compare the initial reading on the gauge to its proper values. There are multiple nuts at the bottom of a combo regulator. Adjust only the end one. The other two are factory set and should never be moved. To change the reading on the gauge, adjust the set screw and retest, again checking the gauge. Keep repeating this until it's at the proper value. To replace the regulator, after cleaning the threads, wrap a few layers of Teflon tape on the threads. Go in a clockwise motion as if you were twisting it on. Wipe on a little halocarbon grease and twist on the regulator. It's helpful if the two 90-degree elbows are already attached. Replace the two pieces of copper tubing and their fittings. Make new ones if there's any question at all about the serviceability of the ones that were there. Twist the fittings onto the copper tube and tighten the fitting nuts. Here's the procedure for upgrading and converting a dual regulator setup to a combo regulator. In addition to the regular assortment of tools, you'll need a cutter and bender for 3/8-inch copper tubing and, of course, a combo regulator. The first part of the process is removing the two old regulators from the cylinder. The copper tubing and associated fittings that are attached to the regulators have to be removed. To remove the short length of tubing, twist the fittings until the copper tube can be removed. Once the copper tubing is out, the two regulators can be twisted off with the help of a large wrench. Some of the elbows will get in the way. They'll have to be removed. Be sure to clean the threads with a wire brush, now or later before you put the new regulator back on. Continue taking off all the fittings. Leave only the two connectors that are welded directly to the tank and the valve. And clean out the threads in the valve as well. Putting a new combo regulator on a cylinder begins with cleaning the threads, if it hasn't been done already, and then wrapping them with Teflon tape. Both connectors have to be taped, and both have to be wiped with halocarbon grease. Next, a 90-degree elbow, Teflon taped and halocarbon greased, goes into the valve. These extenders get placed in the left-hand connection, again, Teflon and halocarbon. Then the new combo regulator gets attached. Another 90-degree elbow goes in the outside port, and another elbow goes into the remaining port. The regulator and the fittings need to be twisted and aligned into approximately their final position. Another 90-degree elbow gets attached to the other connector, and tightening these is never easy because of the top ring. It takes a lot of wrench moving and short twists. Cut new copper tubing to the right lengths and pre-bend them to fit. Insert each length into its respective fitting. Place each end into its fitting and twist it into place. Tighten all of the fittings. And finally, with an installation like this, it's a good idea to test for leaks when the cylinder is under pressure. And neatness counts, wipe off the excess liquid. Here's the procedure for changing the service category of a cylinder. On occasion, you'll need to change the gas that a cylinder is set up for. Basically, you need to change out the pressure vent, liquid and gas use fittings, and change the labels. In most cases, this is okay to do as long as all safety procedures are followed. But never go to oxygen service from CO2 service. That's very unsafe. But for all other service changes, including going from oxygen to any other service, which is okay to do, purge the cylinder with nitrogen and let it sit overnight. And make sure the pressure vent is open while you purge the tank, so whatever residual gases are in that fitting are also driven out. It's important that the entire cylinder, inside and out, come up to room temperature. Once the cylinder is up to temperature and completely vented, remove the float rod and wipe it down with a clean, lint-free cloth. Use a flashlight to inspect the inside of the cylinder for bits of grit or shavings or other contamination. If the cylinder is contaminated, don't attempt to use it, but return it to the manufacturer for refurbishing. But assuming the tank is clean, change out the pressure vent, change the liquid fitting and the gas use fitting. They're different for all gases with one exception. Argon and nitrogen use the same fittings, but they're the only ones. And finally, replace the float using a gauge or a label that's correct for the new service. And replace the old stickers with the proper new ones. A final thought, always put safety first, yours and your customers. If you have any doubts, any questions, call us. We're always working to ensure your safety with our equipment. Thanks for your interest and attention, and thank you for choosing MVE.